here. I'll make an oval. Let A be the area of cross section of container, small a be the area of cross section, and this is fixed. Okay, don't bother anything. The cylinder is fixed here. I'll make a hole so the liquid will start rushing out here. I want time taken to empty the total cylinder. After what time means how much of time will be taken by the cylinder to empty it. So it all depends upon the hole, no? So after at any instant of time, this is at t equals 0. This is at t equals 0. I'll take one more diagram. Very simple idea. There's a very simple idea. Oh, no, the level of liquid. Meanwhile, you try it. I'll color it because there's a basic problem. We do have plenty of numericals again related to this idea. There's a course idea. It is after some time, the level of liquid will be this much. Will I agree? Because the level of liquid will continuously will fall. Yeah, no. Let H be the level of liquid in the container. I'll write it here. Any equation, how to calculate the time taken? This is after certain time t. So what is the velocity of reflex at any instant of time? What is the velocity of reflex? V equal to root of 2gh. Then the flow rate at 1 and the flow rate at 2 should be equal, no? So what amount of liquid per second that emerges out, the same amount of liquid what happened should decrease in the container. Means for every 1 second, if say like a 1 liter comes out here, for every 1 second what happened, the amount of liquid decreasing should be 1 liter. After some time, like a 0.5 liter per second is coming. In that 1 second, what happens? 0.5 liter should decrease in container. Means what amount of liquid per second emerging out, that much of liquid per second should decrease in container. Will I agree? So therefore, I'll put the flow rate equation like this: Q1 equal to Q2. What is the flow rate at 1? Area of cross section of hole into velocity of reflex. What is Q2? Flow rate at 2 should be equal to A into minus of dH by dt. Because why negative sign? The level of liquid decreases. The level of liquid is continuously decreasing. So how to express flow rate? Area of cross section into the velocity should be the flow rate here. So therefore this should be equal to root of 2gh minus a dH by dt. So there should be a by a 2g dt is equal to dH by root h. So this is everything alpha. Later on I'll write it. So this will be h to power of minus 1 by 2 dH. Now, what is the time taken to empty the total cylinder at t equal to 0? What was the level? I'll measure h. The level of liquid was capital H. Then finally it will become 0. So you tell me from H from where you are measuring. I think H I should measure from here, no? Initially, what was the level? Capital H. After some time, what is the level? Small h. Finally, after long time taken for to empty the vessel. So time taken to empty full cylinder. So we'll agree the limit. At t equals 0, what is the level of liquid? Capital H. When it becomes empty, what is the level? Level will become 0. And there is a time taken. So this will become alpha t minus of h to power of minus 1 by 2 plus 1. This is a general equation. Please do remember the data. 2 will come. So minus 1 by 2 root h will be there. What is alpha? Alpha we have substituted this much, no? Alpha will be a by a root of 2g. So this should be capital A by small a. So this is a total time taken. Let me write it here. Okay, you see total problem is visible. Okay, now what I suggest, there's a generalized formula if you can remember. Depending upon the questions, what all they ask, no, we can manage. Time taken to empty the cylinder. Okay, if the vessel is broader, definitely capital A will be more, no? It will take more time. Now, if you make a big hole here, if small a increases, T will decrease. Definitely, if you make a big hole, what when the more water will rush out. It will take less time. So what is small a? Small a is area of cross section of hole. Capital A is area of cross section of vessel. Vessel or cylinder? This limits, okay? These limits are very important. I'll just shade it so that it will be